was the most biggest animal walking on our Earth? Was this giant bigger than any modern animals we can observe on our planet? How large were the dinosaurs, and how do we know that? In this video, we will talk about the scientific paper about the Titanosaur, and it will concern the more recent research in this field. And I can assure you, you'll be surprised how much new information we're discovering every day today, and how much more we can discover in the future. Although it seems like it's a very ancient science subject, however, there's so much unknown and need to be clarified that hopefully this video will encourage you to dig deeper in the direct and all other meanings of this expression. So let's today look at this paper, and I can just before tell you the story why I come out to this paper, why I choose specifically that one, and why now. And this paper talks about one of the biggest dinosaurs being recently discovered, and there's more speculation about its size, about its genealogy, how it's evolved, what it's relative to. Maybe as me, you will be the one who not that familiar with dinosaurs. I've never been into dinosaurs personally. I'm more like the geological, climatological aspects of that period. I was questioning myself why they were so big, why they die out, how long ago they lived, and all these sorts, but I never could figure out the names and types and learn genealogy of these animals. So here I can tell you clearly I'm not that familiar with majority of terms that use in this paper, and I'm gonna just look through with you together, and we're just trying to make sense what we're talking about. And it will be one of those examples when I'm trying to look through recently published, or maybe not even recently published paper, and we're trying to understand what's happening in the science community. Is it worth it? Why are people doing this? And all these type of questions. I'll probably be more interested in questions about how those dinosaurs evolved, why they die out, and why originally they started being on our planet. However, I was astonished because we had an exhibit visiting right now New Zealand. You can go and see it in the Papua Museum. We have the Patagonian dinosaurs visiting us in a direct sense. So there's a big exhibit that came last year before Christmas, and it's continue sometime this year. So if you're still watching this video recently since I published it, I encourage you to go and check it out. And there is presented one of the biggest dinosaurs which have been discovered on our planet, and most of them actually were found around Patagonia. And there's a recent discovery which we'll talk about in this paper as well. They found a big excavation site around the farm. I think it's all started from 2000s, and then I think in 1999 they found the Patagoniasaurs, and then they found Titanosaurs already in 2000, probably 8 or 9, and they start digging it from 2013 till 2015. That's what we talk about in this paper. They found out a lot of bones of different Zaurus. It's just a type of dinosaurs which were living their time there, and they not necessarily all come from one site, so they were not died out together, as I understand from description of the study sites. They come from kind of different time periods. However, they found they all came from one geological formation, and approximately they all kind of similar age to the earliest Cretaceous, and it's located in Patagonia in South America. Most of these bones were found in Chubut group, Chubut province. This site is amazing, and it gives us so many different type of preserved dinosaurs, which we could reconstruct mostly fully and figure out the diversity of those dinosaurs living there, what they were eating, how they evolved, maybe how they were surviving, how they were dealing with environment, with the predators, and so on. So today, if you really want to go and discover some new dinosaur, I think there's a lot of interesting sites around Asia, in particular maybe China or Mongolia. I know there's in Kazakhstan, Kyrgyzstan, there's some areas we can find ancient animals. I'm not sure about dinosaurs as much, but the ones that maybe were in a more recent time. But apparently Patagonia is the great place to study these dinosaurs, in particular one of the biggest ones. And if you think about it, Patagonia area, that specifically it was the part of Pangaea continent, and in one of my videos previously published just recently, we talk about that, so you can learn about how the continents formed, how they collide together and then break apart. And we're right now in the peak of the cycle of breaking apart continents, and scientists predict that in the future the continents will kind of shuffle around our Earth surface and end up meeting each other together again, creating the one continent. And that will directly affect the climatic condition on the planet, and of course the animals who live there, or animals or humans, or whoever will be there, lizards, whoever will survive. Maybe just insects will be there, and they will evolve into something like a giant Titanosaur. Patagonia is this preserved place, been since Pangaea definitely, and we have a very good record there. And unfortunately, or maybe fortunately, like some other places which haven't been politically or geographically, or just there was not enough money, local community didn't have enough money, but now they do, or the sites were not very accessible, we didn't have much data from that area. And recently we start getting new sites discovered. Mostly it's, as I understand, around somebody's rancho, or kind of like a farm, people discovering excellently. So the bone of this Titanosaur, as I understand, was discovered excellently by the farmer. And it was the femur bone, one of the biggest bone in the body, you know, this big bone of your leg. And by that, you can straight away see that bone was taller than the person who discovered it. You can figure out that you discover something huge. It's not just a local croc or something you found. Let's come back to the paper. So this paper was published in 2017, and it's just the proceedings into Royal Society Publishing. And I looked in the original ones, but unfortunately I couldn't find like a free PDF copy. And so I got that one. And it's actually quite good because this paper published even later. And she's kind of clarifying what was being published in the first one, which was a very revolutionary paper, saying that the most biggest dinosaur on our planet of all time that we know so far being discovered, Titanosaur. And then after that there was a lot of kind of speculation, how the way they described how they calculate the size and the body weight of this animal, and they figure out, so maybe they a little bit overestimated, because, you know, for some reason, I don't know why, it's important, but there's apparently competition. Oh, this is the biggest dinosaur, oh no, that one was the biggest, and so on. So there's a competition, and so they recalculate the sizes, and they publish this next paper, which we're going to talk about. However, I'm just laughing, of course, about the competition, but there's always to be somebody who claims that somebody did some research wrongly. But it's also very good for the science, because we can come back to the same study, especially if we have physical evidence like the bones, which preserved there, and they did molds of these bones, and they've been exhibited in the museums, and one like we have here. It's a very solid evidence which can come back anytime without ruining them, and recalculate, reassess using modern technologies. We've been studied and have a little bit more progress on that. Let's, after this long preview, have a look at the paper. So the new giant Titanosaur shed lights on body mass evolution among Sauropod dinosaurs. So actually I'm also making a point now that I will probably pronounce terms in these dinosaur studies and the places, because some places are in Argentina and I didn't check out how correctly pronounce. So I'm just apologize for everybody who might be offended. I didn't mean to, I just going through the paper, and if I pronounce something incorrectly, sorry, it's my bad. So let's read the authors. So there's authors from Argentina mostly. One of the scientists was from USA. And it's actually interesting, I'm just going to diverse right now, but it's interesting. I want to mention that when I was looking for the paper about these Titanosaurs, I was finding a lot of papers about how museum workers or scientists had to fit them into the museums, how they were moving them and so on, and rare, you know, putting back and this kind of stuff. Sometimes they didn't fit in one hole, so they're so huge. rather than actual papers about the dinosaurs, how they've been discovered. So that was kind of funny. So there's so many papers which are virtually available, or articles about this, how you fit these dinosaur bones into the museum, but not so many available papers for themselves. But luckily this paper was PDF available for free. Titanosauria was the most diverse and successful lineage of sauropod dinosaurs, apparently. So the sauropods, it's those dinosaurs that look like a long leg, kind of modern giraffe kind of animals with a big body, maybe longer or shorter tail. The ones that they show in Patagonian ones in here in Wellington, they have very long tails, of course. So when you look from the neck, from the head till the tail, it's a huge span. You're going up to 40 meters. And I understand why some museums had problem with it, to fit this length just to display one creature. And sauropods, these animals, and they were eating vegetation, so they were vegetarian, I would say, and they grew into the biggest ones. So sauropods were the biggest dinosaurs that we know that existed. Kind of characterized by, if you remember, Loch Ness, kind of small head, very small head, longer neck. Some of them been estimated 4 times longer of the biggest ones than the neck of modern giraffes. And big bodies, very big stomachs, actual belly, where they digest the food, and the tails. And they had big bones protecting, the belly, of course, a lot of vertebrates, and very tiny heads. And I think they didn't even need teeth, so they had only these sharp teeth that helped them to bite vegetation, but they didn't even chew the vegetation like the biggest ones, because they didn't need to develop muscles. They couldn't have big muscles on the heads because they had bigger heads, like a predators, dinosaurs, T-Rexes, that's the one I do know, name on the dinosaurs. And they had these big jaws, and they have to have very strong muscles, so they have to develop big thick necks. They have to be shorter and all this kind of stuff. But these guys, because they have very long necks, and look at our giraffe today, they have tiny little, face. So they, in comparison with the body, of course, so they developed this similar evolutionary thing that they don't need to chew the food, they just swallow it quite fast into the belly, and then it's very long digested there. And apparently scientists say that the food at that time was much more richer in terms of vegetation, because there was more carbon dioxide in the air, so it's not always a bad thing that you have a lot of carbon dioxide, so it was warmer. It was good for them. They didn't need to grow fur or spend a lot of energy to heat themselves. They had plenty of this vegetation. This vegetation was so rich, it was going to the big forests, maybe like our rainforests, very high, and they could reach these high levels, and that's how evolutionary they excel, by eating food from their levels which other animals couldn't reach. And also they have to grow big, not just because of that, but because the bigger you are, the less chances you've been eaten by predator. So that's one of the main explanations why they become so big. But it's also because they had this very specific physiology, and you can read some papers about this. Partly they have quite sophisticated respiratory system. They could kind of store air within the bones, pockets, and then breathe it back when they need it. I might say something nonsense, but this is learned doing short research. And then they could, digest in long term the food, so they have to have a lot of food. They were constantly eating and having full bellies. But also they have hollow bones, so they were huge, massive, strong, but they not necessarily were heavy, so they didn't have to fight this gravity force. And you can experience on yourself, the moment you put on weight a little bit, you already, feel a little bit, you have to breathe hard, you have to carry your body around heavier, harder, because you're working constantly against gravity. So these animals have a little bit more sophisticated physiology, so they can grow bigger, have longer necks, and head could be very high, and they don't faint because of that. So let's continue reading. So that's why it's sauropods. They're usually like the biggest ones, but this Titanosaur, they were like the bigger group that have been found on our planet, and apparently a majority of them were found around Patagonia. Being the clade, as I understand, clade is like the group, had its major radiation during the middle early Cretaceous and survived up to the end of that period. So they were living a long time. If you think about Cretaceous, It's quite a long time. If you think about Cretaceous, we're talking about span of millions of years. Well, early Cretaceous, then you go to the late Cretaceous, so you're talking about, I don't know, from 80 to 120, 140. So you're talking about a long time. So we're talking about not 1 million of years, not 10 million of years, we're talking about 50 million of years, or even 100 million of years. So that's a very long period for dinosaurs to stay on the planet, survive, evolutionary be there present all the time, if you think about it. Some scientists say we kind of branch out into our modern kind of human Homo sapiens division 3 million years ago. But only last million years we become more or less like we are now, and only last half of the million, or quarter of the million, I think, we had this more evolutionary develop into the modern humans. So it took us a long time. But if you think about us 3 million years ago, it was totally different. Human that time, or animal, if you can say, if you believe in evolution. These creatures lived on the planet, and successfully, because they were very happy and they could evolve for tens, 50s of millions of years. So of course they could develop into these big creatures. So definitely nobody will hunt them down. However, we discover in Patagonia dinosaurs, we discover not just big ones, the biggest ones, there's also the smallest and largest sauropods known. So that's among sauropods, the lineage has the most disparate values of body mass, including smallest and largest sauropods known. And in exhibit in Wellington, they show this little one, tiny one dinosaur. It's kind of cute, and you would think, oh wow, it's interesting that these creatures were there too. Recent findings has improved our knowledge on giant Titanosaur anatomy. There are still many unknown aspects about the evolution, especially for the most gigantic forms, and the evolution of body mass in this clade. That's what we talked before. Here we describe a new giant Titanosaur, which represent the largest species described so far, and one of the most complete Titanosaurs. Apparently Titanosaurs is the second one to the biggest so far. There's another one which not proven because we don't have enough bones that was bigger, and the one that's the biggest is Argentinosaurus, as I understand. But the difference between the biggest Titanosaur and another one that been discovered, I don't think it's significant, so the two bigger ones. Yeah, here we describe a new giant Titanosaur, which represents the largest species described so far as one of the most complete Titanosaurs. So this clade includes the most of the giant species of Titanosaurs and represents the major increase in body mass in the history of Titanosauria. The origin of Titanosaur dinosaurs was inferred to date back to the latest Jurassic, so 150 millions, and recent analysis placed the time of diversification during the early Cretaceous. So you see, so they kind of start appearing in the late Jurassic, 150, and they kind of evolved through to 125 million of years. And also the only that survived until the end Cretaceous. In addition to this diversity, 30% of valid sauropod genera, its clade has a remarkable variation on body size. So that's what they talked about. Yeah, Argentinosaurus, this is the one like the biggest one, Puertosaurus, rough estimates of body mass about 60 tons. Smallest sauropods known to date, estimated body masses of approximately 6 tons. So it's still a lot, yeah? Understanding the evolution of body mass in this clade is key for understanding many aspects of sauropod evolution, including changes in the paleoecology and growth strategies. And that's very important as well when you think about, as I say, just what they eat, how they survive, so nobody hunt them down, how they survived in temperatures, climate changes, how they survived just like moving around the area. And apparently these guys we talked about in this paper, they were living kind of in a foresty, swampy kind of areas which are quite flat, so they don't have to like climb mountains or go through areas very narrow and this kind of stuff. So they were quite happy on the big areas, and Pangaea was a great continent for that. And the growth strategies, I think here, well, strategies long term, you were talking about surviving predators. In short term, it's you have a baby and how you actually carry the baby, and then how the baby fast growing up, this kind of stuff. Because if you have very tiny baby like they have in the eggs, and apparently they had very, like in comparison with the body, it was quite tiny babies. And I guess because they lay eggs, the chances that these eggs survive till the baby be hatched, quite low, and then when the baby hatch, it will be a long time before it become big enough to sustain any predators. It was quite an evolutionary struggle and race for these animals. And apparently some studies show that those specifically Titanosaurs, the baby were growing very fast, so they were aiding the mass of the body very, very significantly in the first years of their life, so they grew big ones fast enough to sustain all this danger. Study shows that they start to note variation in body size in this group during the Cretaceous in comparison with other groups, and some previous studies noted an overall trend to body mass decrease. Nonetheless, recent studies failed to find any exceptional body mass shifts in sauropod evolution during the Cretaceous, a result interpreted as a product of niche saturation achieved during the Triassic-Jurassic. A common problem in studies on the evolution of the body size in Titanosauria has been the lack of well-sampled phylogenetic studies of the group. So we don't have representative nice samples, as I say, from all the representative of the group, especially those considering large-bodied dinosaurs, whose record has been extremely fragmentary for many years. The recent discoveries of more complete remains of giant titanosaurs have revealed new and relevant anatomical data, such as the precaudal axial skeletal anatomy with expanded neural spines in posterior cervical vertebra. So I'm not even reading those names. You can come back to the paper, read them themselves, because I not want to pronounce incorrectly. And it's not clear how they are related to each other and how many lineages experience a drastic increase in the body size among the dinosaurs. So let's understand, and this kind of stuff in any paleo studies, especially if you study dinosaurs, are very hard because we have very limited representative. So you have these guys living that time, maybe several representative, but then you have a big gap, and then you have those other species you found, and you can only speculate or pretend there was something in between or not. When this type of studies, they have to be very restricted. So if we have every million year representative full bones collected, and we can study, measure it, and we can see some kind of progression or regression, that'll be great, but we don't have this record. And another thing I heard about from scientists, that some bones could be, especially in the past, they describe them, how they find them, and maybe the methods were not as clear, or the always human factor, the data could be not collected correctly, or somebody forgot where they put something, and then those remnants will be all lost, or just from wrong handling they'll be just falling apart, and we cannot estimate what would happen. And then you will have this record which you think is this, but apparently it wasn't specifically like that, or you cannot measure those bones and re-estimate how big that animal was, or was it one animal, or you actually found remnants of several. So it's a little bit complicated in this field, and I understand there will be constantly papers published, and there will be forcing back, trying to figure out what is the truth. And I hope it always will be the battle for the truth rather than the battle for, I found the biggest dinosaur, or that was my research. It's more correct, I re-estimate. Because it's quite common as well in the science communities, when people trying to just prove the point just because they spend so much time studying it and so much funding, and they think that they know more than anybody else. So they summarize what they do in this paper. We describe a new giant titanosaur, which not only represents the largest sauropod described as far, but one of the most complete titanosaur taxa recovered to date. And they suggested that this gigantism, extreme, gigantic animals were existing, and it's happened during the Middle Cretaceous. And there's a major deviation from the ancestral sauropod body size. So for many million years, they didn't grow so big, and then they start growing so big. Get very comfortable, I guess. So here they explain the Patagonia, Patago, and Titan means Greek divinity, Titanic, It's as well from that word, meaning the big, the large, and so on, large size, strengths. And also in this name, which is Patagonian Mairum, they use the Maya family. That's the people who the scientists stay with during the field work, and that ranch, La Flecha. And it's interesting here they describe that they found these recovered bones. There is not big difference in between in size, and that's why they're saying that we concluded that material collected in this quarry identifies belonging to the same taxon. And they describe this in specifically the methods and data in electronic supplementary material. I didn't look at those, but you can do. I think they will be, if this is for free, so they will be available there for free. And they describe which bones they found and who they belong to, one species to 6. As I understand it, they distinguish 6 animals by themselves. And they were distributed in 3 distinct horizons, and as I say, they were kind of from different places. So they were not like one burial of these animals, they come from different times. And they explained here there was a quite fine-grained sandstone material with mudstones they've been lying in, so it wasn't very dramatic, like a big flood or something that killed these animals or moved around the remnants of the dead bodies, or then just the bones, for example. So they preserve kind of next to each other and intact because of that, because of its nice low gradient, low energy depositional settings. Death of young adults at the same place in different events indicates site fidelity of individuals that died close to water bodies, floodplain, as seen in sites with recurrent deaths of prime age male elephants. Elephants, it's the biggest animals right now on our planet, and many people kind of comparing those bigger dinosaurs with the elephants. So the elephant, bush elephant of Africa, the biggest one so far on our planet, not counting the whales, of course. Whales live in the water, and they have a little bit different system of supporting the body weight through the buoyancy in the ocean, and that's how they kind of cheat, and they can be bigger. And actually one of the biggest dinosaurs, I think, on this planet, maybe they were like on lengths, in terms of the lengths, longer than the biggest whale right now on our planet, but the body weight probably not. So we have to cherish our little whales. Watch my video about the whales. I have a paper talk about the whales as well. So diagnosis, though they talk about all these vertebrates, and I'm not I'm not gonna even go there. I'm not like very specialized in this comparative diagnosis. So they described how they compare it, and they have more specific differences in comparison to the vertebrae of those creatures. And again, if you have a desire to read and argue about this, you're very welcome. Then they described actually the bones, and they have a very nice picture of it. So that's the pictures, very nice, photographed and described everything. And as I told you, they have molds of all of these bones, and that's the ones that you see in the museums, because I believe these bones should be kept in particular temperature in particular boxes so they don't deteriorate. And they're probably with a scientist all the time. So they described every bone, and that's what you do. The study dinosaurs might sound very romantic and interesting. It's only probably the day when you discover the new one, but after that you spend a lot of hours, first of all digging it out, and then describing it, photographing it, and just spend hours trying to figure out the puzzle of these creatures. So here again, there's all these descriptions and morphology and how the bones are corresponding to each other, so I'm not going through this again. They looked into the tissues of the bones themselves. So when you see the paper, you think, oh, people just write this paper, that's a lot of work. You should go check it out, the supplementary materials. And when you're reviewing the paper, you have to go through those, and you have to not just read it through like we're doing right now. You have to understand what they're writing. Every word, every citation should be checked and known for you. That's why you've been asked to review the paper only if it's in your field. And if you're not confident, you can say, no, I'm not interested in reviewing this paper because I'm not as in detail can be a representative specialist. So here, body mass. So they described how they actually calculated body mass. So as I understand, they use 2 different methods, and probably there are more today. I'm not sure. I told you I'm not in this field. So they estimated through scaling equations So quadrupedal, that's the type of quadrupedal, 4 legs, kind of basically dinosaurs. In comparison with some, for example, T-Rex, we talked about, they would walk on the 2 legs, yeah? So they're using femoral and humeral circumferences and volumetric methods. And as I understand, one method will be better if you have enough bones, and other method will be better if you have all the bones, kind of the more bones representative or particular bones. And you can look in the supplementary materials when they describe how to do this. And as always, you see the standard year, so they estimate the size. For example, they estimated Patagotitan body mass 69 tons, and they say plus minus 70 tons standard era, which is 10,000 kilograms, or over the 15%. So you can see that there is still, even when they say, for example, it weighed at 69 tons, but still you have this error, plus minus. Because it's impossible without actually weighting actual animal, because all this tissue, we have bones, we can weight the bones, but all the blood, all the liquids, all the tissues, muscles, ligaments, the skin, the teeth, whatever they had, some of them have feathers, maybe they don't weight as much, but when you weight all the creature, and maybe some creatures were more chubby or some muscly, so there will be very different, plus minus sizes. Patagotitan and the notes overlap between 59 tons and 64 tons, minimum and maximum body weight. So it's quite a significant difference. So if you are really into, this is the bigger one and this is the next one, you have to be very certain. And I don't see the point. They were huge, they were gigantic, and plus minus 3-5 meters or 10 tons doesn't play a role. If you're gonna meet this guy in the field, I don't think this 5-10 tons difference gonna play a role. I will say, okay, I can take a couple more tons, but not but not 15. Nah, I think they're the biggest ones who walk this planet, and I'm happy that the scientists kind of dig deeper and make it more specific, because it helps them to understand genealogy of these animals, how they evolved, why, and so on, how they grew. But in the sense of competition, as I say, I don't think it's a good idea. Yeah, they're saying that the amount of the soft tissue reconstructed, it's uncertain, and result of estimates 45, 51, 77 tons, depending on the amount of soft tissue reconstructed. And that's exactly what I told you. You know yourself, when you go to the gym and you're exercising, you weight more, but you look like you're skinny. But when you don't exercise and you kind of having this fat, you look much more volumetric, but in terms of the weight, the fat is actually lighter. So these are some speculations about this calculation, the body masses, and there are 2 different methods, and they speculated which ones will be better for what and what the difference they show. So you can have a look closely in detail. It looks like these guys spend a lot of time calculating the body masses of the dinosaurs, but what else you can do? And then they talked about phylogenetic analysis. So this, as I understand, because of the data of the size and which bones they have, how big they were, and this kind of stuff, morphology, physiology of those animals, they can put them into the whatever groups they belong to, who they're relative to. And this is a very specialized area, especially if you're not studying dinosaur nerd like me. So for me, it will just be probably enough to see where we are, and then it's evolutionary as well, how it's changing. So they show these Patagotitans here, and they're kind of going from early Cretaceous, as I say, mid Cretaceous, they kind of evolved and branch off, and we have this Argentinosaurus, the biggest one that we know so far, yeah, and these Patagonia Titans. And you can see that they we don't see where they are after the late Cretaceous. That's rather interesting. As they say, after that they disappeared. And we have the 66 million years ago, of course, when most of the dinosaurs die out event, and I talked about this in my Don't Look Up movie discussion video, and we kind of talk about this because that's one of the recent event, recent for our Earth, how it was affected, similar, which was kind of supposedly happened in the movie. So if you haven't seen it, there's a link. And there I talked about the dinosaurs, how they basically, most of them died, and why when this collision happened. And majority of scientists say, of course, these sauropods, they didn't survive. They were one of the biggest ones, the one that died out first. And it's kind of shame, they've been for so long time, they've been evolutionarily successful. And then, uh-oh. So let's have a look in discussion, and there will be a summary of what we should know from that paper. Our analysis reveals the presence of previous unrecognized diverse lineage of Patagonian Titanosaurs that includes most of the largest known Titanosaur sauropods. And I just remind you that this happened very recently. They only found, as they say, firstborn was found 2008 or something, but 2014 the first data been excavated, and basically first papers that published from that time, so it's very, very recent. A lineage includes some of the smallest titanosaurs known as far. The optimization reveals that body mass was largely stable along sauropod evolution during the Jurassic and Cretaceous. As previously people suggested, infrared body masses for most of the basal nodes of Eusauropoda range between 12 and 15 tons. Within Titanosauria, however, multiple events of body mass changes are inferred based on the optimization, as expected given the clade includes some of the largest and smallest known sauropod species. Our analysis reveals a single major event of body mass increase at the base of the clade formed by Notocolossus and Longosauria, implying a threefold body mass increase, 38 to 60 tons, with respect to the body mass reconstruction of most nodes within Titanosauria, 12 to 20 tons. And they say that this diversification coincides with small similar events in other archosaurians in southern hemisphere, theropods and crocodiliforms. And they say it took place during a global period of major environmental changes, which include a warmer climate, onset of the dominance of angiosperms in continental environments, different type of vegetation, establishment of the particular mid-Cretaceous fauna in Gondwana that lasted until the Turonian. And here they described the authors, the input, where you can find the supplementary data. They don't have any competing interests, and they have the funding, of course, and acknowledgements. And you can see that they acknowledge these Mayo and Catalan families during their expeditions. And here you see the list of references, of course, and you're welcome to check it out. So here we go, that's the paper, and I hope it wasn't too boring for you, me reading it. I hope you enjoyed it, share it with everyone, and I'll see you in my next this type of videos when we talk about some scientific papers or just about some science theories.